Hi everyone, welcome to the Hamilton tutorial series. In this video, we'll learn the core of Hamilton, how to define a data flow. A data flow is a directed acyclic graph of data transformation. In Hamilton, there are three constructs that you need to be aware of: functions, nodes, and data flows. A function is a piece of code that you write as a user. It's the Python code itself. There's nothing special here, it's just regular Python. Then there are nodes, which is a construct that Hamilton will create from the function definition that you wrote. And then there's the data flow. The data flow is the structure of nodes and how they're organized together, and Hamilton will take care of it automatically for you. As you see on my screen, there's the Hamilton VS Code extension installed. I highly encourage you to use it as we go through this tutorial series, and you can learn more about it in the first video of the tutorial series. So let's go straight to the code. I'll import pandas as PD, and I'll write my first function. This will define a node in my DAG. I will call it Titanic data, and it will return a pandas data frame. As you see, there's a very snappy experience with the VS Code extension simply by typing this function signature. This is called a signature. It tells you the name, the parameters, there's none currently, and the type, the return type. So just by typing the function signature, there's something that appeared on the right. This is a node, this is a data flow with a single node, and there's a legend that tells me that this node is created by a function. It shares the name of the function, Titanic data, and its return type. This means we created the first node. Wasn't that difficult, right? But we need to add the logic of that node. We will simply return the value read from a CSV that's located under the data folder that's here on the left. And it's called Titanic train.csv. Now, to create your second node, all you need to do is write another function. And what's magical about Hamilton is that you can specify the dependencies and how different nodes relate simply by specifying the parameters of the function. So we will call this processed data. This is very arbitrary. And you see, the VS Code extension already makes recommendation based on the other nodes that are available. It tells you it's a node and it's from the extension. So I can click on it and it will fill the function signature with the name of the node and the proper type annotation. In Hamilton, it's important to have type annotations everywhere, otherwise there will be errors. And also that the type annotations match. So Titanic data returns a pandas data frame, and here Titanic data is also a pandas data frame. I will return a pandas data frame again. So you see, as I completed the function signature, another node appeared. Again, very snappy experience, and as your data flow grows, everything will be available here. We can also click the outline menu, and by default, you only have Python, which will tell you there's a Titanic data and the process data. But if you go to the VS Code, you'll see that there's only two, because there's only two nodes defined. And as we get more complex data flows, this is a very helpful menu for navigation. So we'll keep this very simple. We'll say like Titanic data dot fill null values with zeros. And what's also great about Hamilton is that it encourages you to break down your data flow into small operations. In this case, this could be all like a few lines of code, but here you have clear interfaces between operations, and you can also add doc strings. So why did you do this operation? So make sure there's no nulls for downstream ML algorithm. This is arbitrary. I'm just making things up on the spot, but there are many algorithms that cannot handle null values, so it might be desirable to fill it with zeros. There are many reasons why you maybe shouldn't do that, but that's more of a data science discussion. And then let's create another node. let's write some, let's say, prediction targets. Prediction targets would be like the Y of our ML model. So we would take a single column from that data frame. Prediction target, and it will depend on process data. And you see what's nice in the suggestion, we also get the doc string. So this is helpful again when you have large projects and it might not be easy to make sense of the names of the nodes by themselves. And in this case, we'll return a pandas series. And you see again, it updated the visualization, and we'll take the process data and take the survived column. Again, we can turn the visualization with this button here. This is very simple so far, I hope, and I hope it was easy to follow. Things that are important to remember. The name of the function is the name of the node by default, and in Hamilton we like to use nouns because they're names of assets. They're names of things that can be computed, and this will make sense as we go through the series. You must use type annotations to specify your DAG, and you should be able to just write your functions and Hamilton will take care of building the data flow. This is a very unique aspect of Hamilton. Usually you would have to specify somewhere that, like, maybe in Airflow it would look like this. Titanic data goes into process data, and then process data goes into prediction targets. But with Hamilton, your data flow definition is always up to date because the definition is self-contained. Like the definition of the DAG, the data flow is self-contained in the definition of the nodes. And this is very helpful for maintainability because if you are to edit the nodes, you know that it won't break other places where the data flow is used or created. In the next video, we'll learn how to execute this data flow definition. So far, we only defined the data flow, and next we need to produce results and values that we can inspect. Thank you. See you in the next video.